Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, we are students from 2SE2 Group 3. In this video, we will present our project called Figure Calculator app. Our group members are myself, Atsiilah Wicaksono, Atsiilah Thufailah, and Rizky Fajar Ramadhan.
There are three frames in this application: main menu frame, plan and solid figures frame, and calculation frame. The first is main menu frame. This is the first frame that will appear when we open the application. On the main menu frame, there's the name of the application and its function. Figure calculator. This app will help you to calculate figures like area, perimeter, volume, and depend on what kind of figure that you select. And there are three buttons that we can choose: plan figure, solid figure, and cube. When we select plan or solid figures, it will be directed to the frame that displays the choice of figures that we want to count, and the application will close if we choose quit. And there is a close button to close the application and minimize button to reduce the size of the application window.
After selecting the option in the main menu frame, there is a plan and solid figure frame. If you choose plan figure frame, there are three options that you can choose: square, circle, and rectangle, according to what you want to calculate. And also there is a button to return to the main menu frame. And if you choose the solid figure frame, there are three options too that you can choose: cube, sphere, and cuboid, according to what you want to calculate. There is also a button to return to the main menu frame.
Calculation frame. This frame is the place where the calculation can be happen. At the left image, it is for the plane figures, which can help to calculate area and perimeter. For the right image, it is for solid figure, which can calculate for volume and surface area. So this frame can be divided by two. Is it for plane figure, which can help to calculate area and perimeter, or solid figure, which can help to calculate volume and surface area. Now it is the time to talk about our principle that we use on our project. Before we talk about that, we want to tell about the parent-child relationship, so to make it clearer which one is the parent, which one is the child. It can be seen from the diagram. From the uppers, it is figure that have child solid figure and plane figure, and the solid figure and plane figure have a child itself. For the solid figure, the child are sphere, cuboid, and cube. For the plane figure, the child are square, circle, and rectangle. The first of the principle that we use is inheritance. Inheritance means that it will inherit all the function, method, properties from its parent to its child. There's two images on the presentation. The left image is a plane figure and square is at the right image. The plane figure have a method called figures. So this method will be inherited to a child, which the plane figure as the parent and the square as the child. So the figure method will be inherited to the squares. So the square have a method called figures that get from its parents. Encapsulation. Encapsulation can be defined as encapsulate a variable from a class. From the image, there's a variable that we want to encapsulate. It is volume and surface area. We use encapsulation to place the formula to find the selected figure's volume or surface area. There's a method called setVolume with the parameter LL, which it means it stands L for length, W for width, H for height. And the code block is this volume equals to the L times W times H. So for the set volume, it is the place where we assign the volume formula for the cuboid. And then after we assign the formula of the volume, we want to get the value of the volume after we assign the formula. And to get the value of the volume, we use the method called getVolume that in return it will give us the volume value. And the same goes for the set surface area. For the set surface area, this method is the place to assign to the formula to find the surface area for the cuboid. And then after we assign the formula of the cuboid, the formula of surface area of the cuboid, we want to get to the value by using get surface area, that in return it gives us the value of the surface area.
The next object-oriented programmer implementation is polymorphism. Polymorphism is usually used to implement a function from the base class, which we can call the parent class, and the function will be passed down to another class, which can be called children class. This aims to give freedom to classes that use interfaces or inheritance to use functions according to their original definitions, or to adapt these functions to the behavior of the class itself without the need to create special functions, which are basically almost similar to the functions of interface or inheritance. In other words, polymorphism uses this function to perform different actions, so we can perform an action in different ways. In this project, we create a figure class as the parent class, which will derive a figure function that returns a string with the sentence "figure can be divided in dimension." The function will be passed down to the children classes, namely plane figure and solid figure, where both classes inherit the figure function but with different sentence. The plane figure will return with the sentence is a two-dimension figure, but the solid figure with the sentence is a three-dimension figure.
The next object-oriented programming that we use is abstraction. Abstraction is the process of hiding certain details and showing only essential information to the user. The difference between abstraction and inheritance in the application of their functions. If we derive the nature of the abstraction class, the function that is made abstract must be applied or created to the class that inherits that property. And on the presentation, the left image is solid figure as a parent, and the right image cuboid as a child. Abstract function in solid figure is applied in cuboid class, which inherits that property.
Now it's time for the conclusion. The conclusion is there's 3 frames on our figure calculator app. There's a main menu, plane and solid figures frame, and calculation frame. And for the all principle that we use on our project is inheritance, encapsulation, polymorph, and abstraction. That's all from us. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.